Hey guys, this is Mrs. Lyons, and this video is going to cover our introduction to our bonding unit. And today what we're going to talk about are the different types of bonds. We're going to talk about two types of bonds, ionic bonds and covalent bonds. So a couple of things that we already know, atoms. Okay, when we have an atom, a neutral atom, that means the number of electrons and protons are the same. Okay, because protons are positive, electrons are negative, so they have to cancel each other out in order to have a neutral compound. And we also know that when we have charges that are not the same, when we have a different number of protons and electrons, we form something called an ion. Okay, so if there are more electrons, the charge is going to be negative. If there are fewer electrons than protons, the charge is going to be positive. Okay, so we look at this sodium ion. Let me back up. If you look at this sodium atom, you have 3 energy levels with 1 electron in the outermost energy level. When we look at an ion, we lose that outermost shell, and now our outer shell has 8 electrons, and our ion only has 10 electrons. Okay, which gives it a positive 1 charge. Okay, something that's going to be very important for us to understand in this unit is the octet rule. And the octet rule says that all atoms are going to be most stable when they have 8 electrons in their valence shell. All right, so when forming bonds, what's going to happen is electrons will be gained or lost or shared so that that outermost shell has 8 valence electrons. So for example, if we look, remember you should have written on your periodic table above each group how many electrons every atom in that group has, how many valence electrons, excuse me. So for example, if you look at your periodic table and you see magnesium, element number 12, magnesium is in group 2, so it's got 2 valence electrons. Okay, so what atoms are going to want to do is they are going to give away their electrons. Okay, so in the case of magnesium, it would give away 2 electrons because that would eliminate that outermost energy level, and then the next energy level in would have 8. Okay, so magnesium is going to want to lose 2 electrons, and if it does, it's going to have a +2 charge. Okay, aluminum is in group 13. Aluminum has 3 valence electrons. Okay, so it is going to want to lose those 3 valence electrons, giving it a +3 charge. All right, now when we get to oxygen, oxygen is in group 16. All right, so oxygen has 6 valence electrons. And the thing you want to remember is atoms are lazy. They want to do what's ever easiest. So when I say that, what I mean is atoms are going to want to gain or lose the smallest number. So while oxygen technically could lose 6 electrons, the easier route for it to go is to gain 2 electrons. And if it gains 2 electrons, then it has 8 electrons in that outermost valence shell. And because it gained 2 electrons, it's going to have a -2 charge. Okay. Chlorine is in group 17, so it has 7 valence electrons. Again, it's going to be easier for chlorine to just gain 1 electron than it would be for it to lose 7. So it's going to gain 1, and it would have a -1 charge. Now, if I were you, what I would do is go onto my periodic table, and I would write the charge above each column that tells what charge. So, for example, everything in group 1 has 1 valence electron. It would lose that valence electron and have a +1 charge. Everything in group 2 is going to have a +2 charge. Everything in group 13 is going to have a +3 charge. We're going to skip group 14 because those elements do a different kind of bonding. But then group 15 are going to have a -3 charge, group 16, -2, and group 17, -1. So I would write that above each column on my periodic table. So as you're going through, you can look at that. Okay, so our first type of bonding is ionic bonding. And ionic bonding happens when a metal and a nonmetal combine. What happens is the metal is going to give up its valence electrons to the nonmetal, and this creates an ionic bond because the positive and negative charges attract. All right, the metal becomes a positive cation, and the nonmetal becomes a negative anion. Remember, cat ions are positive because cats have paws. That's the way to remember that. All right, so metals form cations, nonmetals form anions. All right, those charges, the positive and negative, are attracted to each other. That's what causes this to have an ionic bond. Okay, ionic compounds. When we make ionic bonds, what happens is the structure, they form this crystal structure, which is the positive and negative charges lining up so that they're perfectly aligned. All right, ionic compounds have high melting points, high boiling points. It means it's hard to get those ionic bonds to come apart. Ionic compounds, almost all of them can be dissolved in water. That means they're water soluble. And they can also conduct electricity when we dissolve them in water. They can actually conduct electricity also if we melted them. So if we heated them really, really, really hot and we got them to melt, the molten, we call that molten, compound that is in a liquid state would also conduct electricity. All right, covalent compounds. That's our other type of compound we're going to talk about. Covalent compounds are made up of at least 2 nonmetals. The ones we're going to talk about are just 2 nonmetals. And what happens is those 2 nonmetals share electrons with each other in order to give them 8 electrons in their valence shell. All right, properties of covalent compounds. Ionic compounds are all solids at room temperature. Covalent compounds can be solids, liquids, or gases. There's a lot of variety in covalent compounds. Covalent compounds have low melting and boiling points. Most of them do not dissolve in water, which means they're insoluble. And they also do not conduct electricity or heat in any state. All right, so when we name, we're going to write names for our compounds. That's another part of this unit. And when we name covalent compounds, we're going to use these Greek prefixes. And I'll be getting you a new periodic table that has those on the back side of it. But for now, you can use your packet. So you've got a list of the prefixes here, okay? And you're going to use those prefixes to tell how many of a certain element there are in a covalent compound. So here's what we do. The first thing we do, we look at our compound, we write down the name of the first element, just like it appears on the periodic table. And this is usually the element closest to the left side of the periodic table. And then we add the prefix in front of that element's name. All right, one exception. If there are only one of the first element in the compound, we don't use mono. It's just assumed that if we don't write a prefix, there's only one of them. All right. So then we write down the second element, but we change the ending to IDE at the end, and we add the prefix in front of the element's name. All right. These are how we would write the second element, how we would add the IDE. So you should probably get used to how these sound and how they look, because spelling does count. All right, so nitrogen would be nitride, oxygen would be oxide. Notice what we're doing is we're taking the first syllable and we're adding IDE. Sulfur would be sulfide. Selenium would be selenide. That one's a little different. There we go. Fluorine would be fluoride. Chlorine, chloride. Bromine would be bromide. Iodine would be iodide. That one sounds a little funny. All right. And then generally we are going to remove any double vowels that happen between the prefix and the name, unless that vowel is an I. Okay, so for example, if I had 4 oxygens, I wouldn't say tetraoxide, I'd say tetroxide. Okay, the only place that happens is in iodide. All right, so let's look at some examples. All right, so we've got N4O5. Okay, so this is going to be nitrogen oxide. Okay, but we need prefixes, so it's going to be 4 nitrogen. So the prefix for 4 is tetra. The prefix for 5 is penta. So this is going to be tetra, hold on. Oh, there we go. Tetra nitrogen pentoxide. So notice we don't do pentaoxide, we just do pentoxide. All right, the second one, we have 1 carbon, 4 hydrogen. Remember, we don't use mono. So this is just going to be carbon tetrahydride. All right, CO. Okay, there's only 1 carbon, so it's going to be carbon. Now there's only 1 oxygen too, and we do use the mono when it's the second element. So this is going to be carbon monoxide. All right, we can use the same process in reverse to write formulas. All right, so tetraphosphorus hexoxide, okay, is going to have 4 phosphorus, and hexa is 6, so 6 oxygen. So it's going to look like this, P4O6. Disulfur triiodide. Notice there's the double vowel that we don't eliminate when it's an I. So this tells us we have 2 sulfur, 3 iodine. So disulfur triiodide. And then finally sulfur monoxide would just be SO. All right. So hopefully that is a good introduction into the different types of bonds that we're going to talk about, and then naming these covalent compounds. All right, I hope this helps. Take care of yourself. I'll see you in class.